Describe the transformations involved when y equals the absolute value of x is transformed to y equals negative 1/3 the absolute value of x plus 2 minus 3. I have written to the right what I call the key to life, the abbreviated version of it, where if I understand where the numbers are placed in my parent function, I'll know what they mean and what they did to my parent function. First off, I can look here at this negative, and I'll look at the key to life, where it says that I have a reflection about the x-axis if I have a negative there. Since I have a negative there, that means that there's a reflection about the x-axis. If I didn't have a negative there, I wouldn't even have to worry about that. If it's positive, that means nothing happened. Now, I'm going to look at the 1/3. The number in front of the parentheses, in my key to life, it's A. The number in front of the parentheses means I have a vertical stretch or compression. Again, if there's no number there, then that means that I don't have to worry about it. There's nothing there. There is a number there. The number is 1/3. So I look at my key to life, which says that it's a stretch if A is greater than 1. It's a compression if A is in between 0 and 1. 1/3 is in between 0 and 1. It's less than 1, but greater than 0. So that means that since it's a third, which is between 0 and 1, I have a vertical compression by a factor of 1/3. If it was a 3 or a 4 or a 15 in front of my parentheses, which I'm treating my absolute value sign symbol as parentheses, but if it was a 3 or a 15 there, then it would be a vertical stretch because those numbers are greater than 1. Since it's a 1/3, it would be a compression, the same as a 1/2 or a 0.3 or a 0.8 or a 0.2. Those are all less than 1, but greater than 0, so those would be compressions. All right. Then I look at if I'm adding or subtracting a number inside the parentheses, that would represent the horizontal shift, left or right. With horizontal stuff, you have to think backwards. So normally, left is when you have a negative, but in this case, it'll be a positive. So when I'm looking at this, I have a positive 2 here. A positive 2, I'm looking at my key to life, it says that it'll be left if it's an x plus 2. I mean, x plus h, x plus a number. So I know that I have a horizontal shift left 2 units. And finally, I have a -3 outside of my parentheses. I have something being added outside in the back of my parentheses. In that case, I'm looking here, oops, where it's talking about K, which is a vertical shift. It's up if it's a plus K, it's down if it's a minus K. In this case, I have a -3, which means that I have a vertical shift down 3 units. And I've addressed everything in the problem they gave me. I have my transformations involved to my parent function, the absolute value of x. I have a little note at the bottom of my key to life that says that the vertex is HK. This is because if you're just thinking about this graphically, and now we're graphing it, the original, the parent function, probably looks like this. That's how the absolute value function looks. If I know my vertex, which is H and K, then, well, yeah, if I know my vertex, which is H and K, then I'll know exactly where it moved left or right. In this case, my vertex here is -2, -3. You have to think backwards again. H is -2. You always change the sign, keep the sign. So if that's my vertex, if I remember that I change the sign, keep the sign, if that's my vertex, then I know that I would have moved it -2, -3. It would have gotten moved over here. Same absolute value graph, I just shifted it over. And if you know about the vertex, then that'll help you easily see that I moved left 2, down 3. If you have a graphing calculator, you can just put this into your graphing calculator and be able to see that it was shifted left and down. It was shifted left 2 and down 3.